but only sometimes.
Yeah. Fun fact about Adam is because he started like 6 months after I did, and we were a PHP exclusive shop, and then he complained about Node, that we should be on Node for what, like a year and a half probably. Literally every day was like, we should be doing this on Node, and then a year and a half later, he's working on Node. So, yeah. Andrew? Yeah.
I'm Andrew. I work at Jane.com. Software development.
He's also one of our core organizers, so if you ever need anything, he's the one who organizes the speakers. Over right here.
My name is Andrew. I teach JavaScript to adult learners. I'm semi-retired, and I just like to come to these to keep up on what's new, what's going on. But yeah, I don't work in development. I just teach people how to.
Where do you teach?
Well, so I work for 2U. They do a boot camp, and then I also do some free things.
Nice.
Yeah.
That's awesome. Good for you, man.
I'm Riley Messina. I'm currently in a boot camp. I'm trying not to smell. But yeah, I wanted to meet more people in the area and make some living friends and learn some more, find places where I can learn more. So I'm actually doing the Buzz, which is on this Twitch. Yeah, Neon is awesome.
Yeah, it is.
I adore him.
It's cool.
It's through Twitch.
Yeah.
Oh, I love Twitch, so that's cool.
So I'm Lane Wagner. I was managing a team of Go developers over at what was Newbie and is now Reputation Require. I've always wanted to go to more meetups. I went to a few of the Go meetups, but I want to go to more meetups. I just got funding for a startup that I'm running now. It's called Boot Dev. It's not a boot camp, but it's a kind of code academy or like online learning for backend. So it's Python, JavaScript, and Go. So I'm doing that full time and don't have time to meetups. So.
That's awesome. Sweet. Like, I think we'll get an introduction from AJ here in a little bit, but
Yeah, I'm going to go grab some pizza real quick.
yeah, super happy to have you all here, and we have, just so you know, we've had really good success of people coming and getting jobs after, so hopefully we can, help those people who want jobs to get jobs, and thank you for bringing up some. So we'll wait on him, but any cool things? I know that last time we had a really awesome presentation around new things in JavaScript. I don't know if anybody knows any new releases. I don't think there's anything much that's happening. I know that there is a Next.js conference coming up. I don't know, does anybody here use Next.js? We use it. But
I know that Firefox still hasn't allowed for access to the off-screen Canvas API, and that's making me real mad.
yeah.
I heard a rumor, I don't know if this is true, that in a newer version of JavaScript that's coming up, they're thinking about allowing you to do private functions. I don't know if this is true, but that could be helpful.
That's interesting.
I've got TypeScript.
Yeah.
Well, I didn't say TypeScript, I said JavaScript. That's a
Yeah, just
different
needed
animal.
JavaScript. That'd be nice.
Yeah, you will be learning 0 TypeScript today. TypeScript is forbidden. Verboten. If you wanted TypeScript, this is not the right place to be. Go somewhere else. I don't like you. Can't be friends.
I think 90% of our JavaScript work is actually TypeScript now, so we do push it. What were you saying, Andrew?
This might be good news for JavaScript runtime news. The Dino runtime now supports like 90% of NPM modules. So I'm not sure if that makes sense to anyone, but that's kind of big.
Yeah.
Do you know what it was before? Like what it's coming up from?
What was it?
Like what was it before it was 90%, you know?
0%.
Oh, nothing.
Yeah.
Wow, that's awesome.
Well, depends on how you want to look at it. I think this is actually quite terrible for Dino because now they're not distinguishable from Node anymore. Because Dino was building a community with higher quality modules that you could rely on to be safe.
Do they have their own like namespace?
Mm-hmm.
They still got that, right?
Well, it just muddies it because everybody's going to use NPM and then you're just going to lose it all. And then you're going to have low quality modules that aren't performant, that don't have clean code.
Some more left pad.
It sounds like if Apple were to let all the Android apps into their.
Yeah, exactly.
That's a good analogy.
Yeah.
I think, yeah.
There's a few little like different perspectives on it.
It's that 10%, you know, that 10% they're not allowed, that really just raises the bar of quality.
Well, it makes migration 1,000 times easier, right?
Yeah.
You've got 10
Oh yeah,
times
you like still support the same modules, you don't have to like completely switch over away.
Yeah.
Yeah.
And the other perspective too is from what I read from the article, because the main reason why they were doing npm modules is to try to avoid node modules forward in the repository, so it makes it easier to ship like the application without having to ship all the node modules.
That really small folder of a node modules folder, which can't use a joke. Node modules always check. Yeah.
Well,
Cool. Pass over the time to you, AJ.
okay, well, I'm gonna finish a slice of pizza. I still got, well, really, 5 minutes, but we'll start a little early.
Yeah.
But I guess I can introduce myself while we're waiting. No, I'm just gonna eat pizza.
I can always tell another bad joke. That's everyone's least favorite.
You could tell them a bad joke.
Yes.
So what was I gonna say? Oh, so this is about a 40-minute presentation. My time slot is 20 minutes. I don't know why they gave me a lightning time slot to do a deep dive in JS with types, because that's just not enough. But so we're gonna figure out how to trim the fat on this. I probably shouldn't speak faster. I might skip some of the slides.
I feel like we should just do the 40 minutes and have like, you know how like America's Got Talent has those X buttons? That way you can say if it's not a helpful slide, that way you know which ones are like the value slides, you know?
Hey, 100%. I agree.
Yeah.
I got 48 seconds. Hey everybody online. There's a few people that are online. I can't actually see the chat. Well, let me see if I can. I'm going to try to make it so I can see the chat as well. I'm trying to operate only on 2 screens rather than my normal 6, so this is quite difficult. I don't get to have one screen for chat and one screen for video preview and one screen for doing the work and one screen for secret ops scene.
4 screens is too much. I don't know. What's your 6-screen view look like?
Well,
Is it 3 and 3?
one's vertical, 2 are horizontal stacked, then there's the MacBook itself, and then there's the screen that I actually code and present on. Okay. Oh, my time is up. Last bite. Here we go. Let me make sure that we're sharing the same thing online that I'm sharing here. Okay, cool. Well, hello, everybody here at Utah JS Lehi, as well as those of you joining it online. Thanks, Datman Dark, 2 Nibbles, good to see you. And thank you, Fashion File, for hosting us, providing pizza, giving us a nice place to meet. Really appreciate that. So tonight we're talking about JS with types. And the point of this is types without transpilation. So we could subtitle this, Why Go and Zig Developers Lane Should Not Give Up on JavaScript Yet. Okay, so just FYI, useful links are here on the slides. BeyondCodeBootcamp.github.io will bring you the links that get you to these slides. The video will go here. Everybody always asks, how do you create the slides? So there's the link to that. And then there's some other useful links that I'm going to be putting here as well that are basically a summary of links that are going to be throughout the presentation so you can get to the good material quickly. I'm AJ O'Neill. If you want to follow me on Twitter, it's @_BeyondCode. That's the stuff that I keep it clean and not cynical or sarcastic, but just try to keep it positive and code-oriented. YouTube, on the other hand, no promises. I work at savvy.legal It's a business lifecycle platform. So basically, if you're an entrepreneur, serial entrepreneur, investor, founder, well, we already covered that. It's a system of record and deal room. So basically, all that crap that you don't want to do, but you actually have to do if you're ever going to get investment, you would want to be on Savvy as soon as you can so that you have a single system of record. And yeah, we automate away all the stuff that founders hate, which it's when you realize you need it, then you realize you need it. And so for 2 organizations, I am looking for people to work with, potentially contract to hire type of thing. We're looking for a really good front-end developer, and we are, and then the other organization that I work with is Dash, but I'm going to skip that. So JS with types. Basically, we're going to talk about the TypeScript checker and JSDoc with vanilla JS. If at any point you find any of this, useful, helpful, entertaining, etc., consider like, thumbs up, follow, etc. Those are more links that I'll put in the beginning. So here's this is what we're going to go over mostly, is types of types. Because whether you are coming from a type background or you're not, we kind of need to establish some ground rules. But as we go through this, because this presentation has to be so short, we're going to go ahead and show you the JSDoc as well. And by we, I mean me, because I'm the one actually presenting. So, no, there we go. So the syntax for JSDoc, which is how you give type hints to your JavaScript, it starts with a double star. It's like a block comment, but it's got a double star, and this is critically important. Will not get parsed as a type hint unless it's got that double star. Then you have your normal block comments. I don't actually think you have to start them with a star, but it's convention and it looks pretty. And then you have to end it with a //. So this, when you see the double block, that is for type hinting and documentation. That's what we're going to go over. You can also do it inline, and there's a couple of instances where I find that to be useful, which we'll talk about. So if you want to type something, this is the core thing here, you're going to need to do @type and then the name of the type in brackets. That's the core syntax. And you can put this above a variable, for example. If you want to declare a type, then there are 2 ways to do that. One of them is to use typedef, and the other one is to use callback. Now, kind of a weird thing, a bug for historical reasons has not been resolved. They call it callback. It's not a callback. It has nothing to do with callbacks, completely unrelated, complete misnomer. This is for functions. So if you want to typedef an object, you use typedef. If you want to typedef a function, there is a typedef function that is not supported. @function is not supported. It's just really important that you know that because it'll mess you up because it's half supported in a really weird way. And then you're going to do @prop. If you're going to define an object, you use @prop to define properties of that object. And if you're defining a function, you define @param for parameters that it's going to receive. So now that we've got the syntax bits out of the way, we're going to talk about single value types. So this is really quick and simple. You know this stuff, right? So we've got hello world is a string. Type it as a string. 42 is a number. Remember, numbers in JavaScript are floats or ints. Then you've got Boolean. Now, in fact, it's senseless to do this. This is purely for an example because it is perfectly understandable to the tooling, to the TypeScript checker, to know that this is a string because it's obviously a string. So for all the primitive types, it knows you don't have to actually put any comments on them. This is just for illustration so you can see the syntax. Then there is a couple of special cases that we'll go over a little bit more later, but we have the case of null. So imagine a trinary state. You want something to be true or false, or the user didn't make a decision yet. You still need to present them the prompt. And the null is a question mark. And then there's also undefined, which for the purpose of the type checker, undefined and not defined are treated the same. Null and undefined are not treated the same. So you could do something like this. You can declare the type of something and not actually assign anything to it. If you do not allow it to be undefined, then you must assign a type to it pretty quickly, and it must be the type that matches. But nullishness is kind of its own thing that I need to put in a separate slide on. And if you were going to do a function, this, you do @param, @param, @param. You can use your primitive values there and you can type them. And this is important. It cannot implicitly tell what you expect a function to receive, so you always have to type your functions, but you don't always have to type your variables because quite often whatever you're assigning it from already was typed because it's the function return type. There's also another thing here I didn't put, @returns, that needs to be here, and you can do @returns and then put the type. That's missing from this slide. Okay, so there are some other things that are not quite, well, they are and aren't primitives because JavaScript is a weird mishmash language that has evolved over the years. So you have big ints in JavaScript. That is a discrete type. It is a primitive type. You also have int 8, int 16, int 32, int 64, as well as all of the corresponding uints to those. Those are native in JavaScript. However, you can only access them within an array. You cannot access them as variables. So if you assign something from a typed array, it gets untyped as a number, which is really weird because, of course, later they introduced the big int as its own type. So you have this little bit of mishmash of types that can be confusing sometimes. And then you have other types that can be similar. For example, buffer and array buffer between Node and the browser are essentially the same with a couple of nuanced details. But if you ever want to say that this something can be either, it can either be a buffer or it can be an array buffer. I would only use this for types that are particularly similar. You can do @type, and then you can put a pipe, and that allows you to set that something can be of multiple types.
I've honestly never heard of a buffer. Is that like?
It's a typed array. Yeah, so it's an array that has a specific integer size in it. Typically, when we say buffer, we mean something that is 8-bit bytes. Unless it's specified that they're of another byte size, you can assume that they're 8-bit bytes.
And you showed the function back a little way. So hypothetically, if you throw in alive, but it's not for this particular boolean, is it going to throw an error, or what's it going to do? Is it just going to?
So it doesn't throw because all of this is in tooling.
Yeah.
In fact, that was something I cut, but all types are in tooling. Whether you're, won't go into that. But yeah, so what you're going to get is an error from the type hinter. The type hinter in your Vim or your VS Code is going to pop up and give you a squiggly and say, hey, this needs to be a Boolean, but you passed in null. So you don't get, I mean, this is a feature, not a hindrance. You are prevented from using implicit type coercion. So you can't pass in something that's falsy. You actually have to pass it in as either false or true. You can't pass in a string to a Boolean. You have to pass in a Boolean to a Boolean. Okay. And then there's a couple of other types you might think are primitive types because they have their own special syntax, but they aren't. The primary one I'd say is regular expressions, because regular expressions, there's a literal syntax for a regular expression, but it is just syntax sugar for doing new regexp. And likewise, date is something that we work with all the time, but a date is just an object. You could create the JavaScript date from whole cloth yourself. So these are actually objects. You couldn't do that yourself because we don't have the ability to define new syntax in JavaScript, but these are not actually primitive types. So just from that point. Again, when we're defining a function, and I forgot that returns on this one too, the first line is going to be the comment. So this syntax of jsdoc type hinting gives you two benefits. It gives you strict types throughout your program and little squigglies that tell you, hey, this is what went wrong. But it also allows you to generate documentation where you can see what the types are in your program, you can see what the functions are, and you can see the descriptions of the properties or the things as a whole. So the whole description, the brief summary, goes as the first line, and then you give your definition. So here I'm defining a function called greeter. This is a type of function because I might have multiple functions that are of the type greeter. And then I am defining, this is quite interesting. If you want to pass in an object to a function, an object will have multiple properties. So what you can do is say, we're going to call the object other, and that object is going to have a parameter name that's a string. So you can define the structure of an options object in line with the parameters. It's just, you might have two parameters, an ID and an options object, but you might be defining 5 parameters because you're defining the ID, you're defining the options object, and then you're defining the properties of that options object. So other dot name. Oh, I already went through that. Let's see. Oh, and then, so here was the definition of the function. And then we type a function the same way that we would type a variable. So we can define the function, and then we can assign this greet function of that type. So if you're familiar with essentially everything is an interface in the JavaScript type system because it's duck typed, which we might talk about that a little bit later. So what I already mentioned this, you can't do at function. You can't do at typedef function. Those are the obvious ones. That's what you think you'd be able to do. You can't do it. It's just, and if you like to make some noise on that bug, here's a link to that bug about not being able to use this. Okay, so, yeah, I'm not going to do that.
Is that a bug on JSDoc or on the TypeScript?
TypeScript. Yeah, it is a bug in the type checker. JSDoc, they're all aliases. Whichever one you use, it doesn't matter. They're different syntaxes for the same output. Okay, so what was I going to show here? Oh, and you can, of course, skip the middleman. If you're only going to ever have this one function, then you can skip the middleman and you can just put the parameters right on the function. And again, at returns. I'll have to go and update all those. Before we continue, so we're gonna leave that bit behind. Before we continue, I want to make a distinction between syntax and semantics, because in JavaScript, we have the same syntax for multiple semantics. So in JavaScript, a map is declared with curly brackets. A struct is declared with curly brackets. A block is declared with curly brackets. So the same syntax goes to mean several different things. Likewise, a list is declared with square brackets. A index is declared with square brackets. And you can also use these for destructuring as well. So I want to just draw attention to that just because you see a bracket style doesn't mean that each place where you see that, it means the same thing. So we're going to draw a distinction with these multi-value types and then the collection types. So multi-value types are structs and tuples. Structs, or structure, if you want to say it out long, and tuples are actually the same thing. They're just a different way of presenting information. So I'll go ahead and show you. So a struct is a POJO, meaning it's just a plain old JavaScript object. This is what we call, in every other language, we call it a struct. And it's just, I'll give you an example here. Oh yeah, so we just did this, right? So if a struct is something that has different properties of different types that are all related together. So I am a person, I have a name, that's a string. That's a different type than my age. My age is a number. So what makes these things go together is that we're describing a person in whole, and so we have lots of different types to describe the person. And the structure contains all of those properties no matter what their types are. They don't have to be, we don't have to have every property in a struct doesn't have to be a string. So if we wanted to take this function where we've got multiple params here, so we have an other object and it can have a name and it can have an age. If we wanted to pull that out so that when we define this function we only have one parameter that we're listing here, we could define a struct for these options that are going to be passed into the greeter for these three things. So what we would do is we would type def an object person, and then we would give it properties. So we would do at prop name, at prop age. Now we have the definition of a struct. And we can have a comment up top to describe that struct so when it outputs to documentation it gets it. And I'm not going to do that. We could also have, for certain things, arrays, promises object. You'll see an example of that later. You can subtype it. So if something is a collection type, like an array usually is, then you can give it a subtype and say everything in this array is of this type, or everything in this map, which we'll discuss later, is of this type. So we can have a property that is an array, but we need to say an array in of itself is not a type. An array contains things which are of a type. And so we use this square bracket syntax to denote that this is a person. So we'll say that's their friends. And then if we want to add more description to any of the properties on the struct definition, you just use a hyphen and then whatever your comment is, and that pops out in the documentation. So when you go to use jsdoc to generate the documentation from this, you'll see friends is mutual follows. And then, of course, we can also have a function, but again, just like an array, we can't just say, well, this is an array, because an array doesn't describe anything in of itself other than there's a list. With the greeter, with a function, we'd want to actually give whatever the type of the function is so that we know that when we assign a function to this, it has to have certain parameters that it will receive. It has to be of a certain type. So if you do all of this, ta-da! You now have created a way to do classes and plain old pre-TypeScript JavaScript, because you can assign values and functions and all that other stuff. So you could simply return this type from a function, and if you were to return this type from a function, ta-da! You've invented the constructor. Okay, one important note, prop versus param. You use param for what a function receives, and you use prop for what you attach to an object. And in this particular case, this was not updated correctly, but whatever, because that should be string and name, for example. And I mix these up all the time, and then I get little weird errors, and I'm like, why is it saying that name is not defined? I've clearly defined name as a string. And it ends up being because I used param instead of prop, just because I was copying and pasting or something like that. And you'd think, well, why can't just param be an alias of prop? Because the two things are pretty similar, so why bother me? But it turns out that in JavaScript, one of the great and terrible things you can do is you can actually assign properties to a function. So you can define a function that receives parameters, but also has properties. And you could think of this, the first thing that's coming to my mind would be array. Array has a property, which is a function, is array. An array is also a constructor, or promise. Promise has a property .resolve, but it's also a function that is a constructor. So in JavaScript, it's since a function can also have properties, there actually is an important distinction, because we could do something that's kind of silly. Yes?
So I could test this out on a computer, but not my problem. So you're saying the JavaScript actually reads all of that documentation. If I were to do greet.other, it would then output person or whatever it is. I don't have to actually define what that function does, but because I'm once you're sorry, I'm not explaining it. You're defining function greet right there, right? And you define above in that doc block kind of like the parameters and the props. If I were to just call greet.other without any other explanation, it would give me the other without it needing to be set?
No.
Okay.
So this is probably something that I could clean up because I was just copying and pasting one line to another. No, what I'm saying here is that in general, you can assign an object or a function as a property of a function. A function is a function first, but it is also an object. So it is like an object that you can invoke or call. So yeah, what I put here with putting the double others, I'll make a note to clarify that so it's not confusing.
And I would have to then, because you're passing other in as a parameter, I would within that function have to assign other to the property of other to actually have it output something, right? Which is what you're doing below the function.
Yeah, and I should definitely change this because I did not intend those to be the same other. I was just copying and pasting and changing prop.
No worries. I just want to clarify because I was like, oh, that's a lot smarter than I would have thought.
But you could have both and it would be valid and terrifying.
Yeah, yeah.
Yeah, you could.
Yeah, valid and terrifying. Yeah, so I'll try to clean that example up. Okay, so tuples, if you're not from any other language, then you might hear tuple and think, what? A tuple is just a struct. So the way that we've defined a struct, a tuple is defined the same way. The difference is that a tuple is by index rather than by name. So if I was going to create a tuple, let's just go back here because the example I have on there is not as good as the example that I have back here. So if I was going to create a tuple, let me see if I can just get this. Oh, I've got that unhighlighted. If I was going to define a tuple with all of these properties, the way that it works now is if I want to change the name, I call .name, and then I would assign a different name to that object. A tuple is using the list syntax, or the array syntax in JavaScript, the square bracket syntax, but it would just be the first element is name, the second element is age, the third element is friends, the fourth element is greet. Sorry for one indexing that. But otherwise they're the same. The way that it would get optimized in the JIT compiler is the same. There's no difference. Well, that's technically not entirely true, but essentially true. So let's talk about tuples for a second. You don't see these often in JavaScript because in general people don't, because the syntax in JavaScript is so tightly associated with arrays, people often don't realize, oh, this also doubles over as a tuple. It can be a list, the more proper term, a list, because it's not actually an array, according to the computer science definition. Or it can be a tuple. You can go either one. The difference between an array and a tuple is an array is a list of things that are of the same or similar types, and a tuple is like a struct. It's a grouping of things that don't necessarily need to be of the same type. So here's a good example of defining a tuple. You use the square brackets and you say, this is the type of the first element in the tuple, this is the type of the second element in the tuple, and so on. So if you are a Go or Rust person, then you get this. You've seen this kind of thing before. This makes sense. If you're a JavaScript person, maybe it doesn't. But in JavaScript, the way that we do tuples, instead, we often do destructuring. So we just we pass back a struct, and then we destructure the struct. And that's the conventional way of doing tuples in JavaScript rather than doing tuples. But as you can see here, this is a struct, this is a tuple. Not that much difference. This one, I could call it P, or I could call it error, or I could call it person, an error, or whatever. I'm not bound to what I name it because the position is important. This one, I could swap the positions. I could have it error and then person, but I could not have it error and P, or error and P that way. Because this one, the position is important. This one, the name is important. So that's the difference. So you do have the option to do this. I've used tuples in JavaScript one time. That time was I was doing something with Socket.io where I didn't want to use the big, huge, gigantic Socket.io library. I just wanted to look at what it was sending over the WebSocket and decode it myself. And in order to type it, what it gave me back was a tuple that was an event name, which is a string, and then event data, which was of a unknown format, whatever format the event had. And so I actually copied this from that code and then just renamed it from the name that it was to this, what you see before you. But that's pretty much the only time I've ever used Tuple. It looks something like that. But in terms of talking about types, when you enter the typed world, knowing what a tuple is important so that you can communicate with people effectively. So 3, now we're going on to collection types. And like I said earlier, the difference between structures and collections is that structures are things of whatever type they happen to be, and what binds them together is their purpose. And collections, what binds them together is that they are of like types. So you have a list of people, or you have a map of people. So maps and lists. And again, the distinction between these two is the same. One of them is by an index, and the other one is by position. So I will kind of breeze through that. So here, if you want a list, you don't use the tuple syntax, you use the list syntax, which is array. And then you could say I have a list of strings, apple, banana, grape, whatever. They just have to be strings, and this makes sense. It'd be very weird if you think about it. I mean, you see this in 101 examples for every programming language, but you never in real code have an unbounded list where you're adding multiple things of lots of different types. That just doesn't happen. And again, you wouldn't actually need to type this at all because it's perfectly inferable. The type hinter can look at this and say, oh, well, all of these are strings, good, and it's a list, so it knows what to do. So you don't actually have to put the type on there. But because, let me just go ahead and, there we go. Because JavaScript is duck typed, it cannot know what type something is just by what properties it has, because any given set of properties could match any number of types that have those set of properties, especially if it's something really generic like name. So we could make an argument that, well, maybe the type hinter should be able to figure out there's only one object, one structure that I've defined that has calories on it, so therefore this must be a structure. But in reality, it would just be too complex to do that because there's too many different possible permutations of things with similar properties or similar names and whatnot. So if you wanted to create a literal list of fruits like this, you would need to give what type it is in the list. That way it knows how to interpret these things and how to check them. Now, one caution about that is I've actually seen this even from top JavaScript developers on the internet who, are big bloggers and all that. It doesn't make a lot of sense to type an array because, again, an array is not a type. If you, there are some people that would type this as fruits, but that actually communicates less information. To say array and then fruit is more clear because it's clear that an array is multiple items and it's clear that the multiple items are of type fruit. If you were to do this and someone sees that in documentation, then they would have to go back and find out, is this meant to be a list or is it meant to be a map? So I would recommend you not typing an array or typing a map in of itself because you lose information. The things are important, not the collections. And then a map, this bracket syntax, this should be brackets, not squares. Curly brackets, not squares. But if you want to type a map, it's very similar to how you type a list. Object dot, and then the key type, and then the value type. And this has something interesting about it. So if you look at this, key type, value type, you think, okay, well, obviously, I can have different types of keys, and I can have different types of values. I could have a map that maps a string and fruits, or a string and vegetables. But it turns out, actually, I'm not going to do that one. It turns out that you can't do that quite as you might think, because a map in JavaScript can only have a string as a key. It cannot have a number as a key. It cannot have a Boolean as a key. Wouldn't even make sense. Anything that you try to use as a key in JavaScript will turn into a string. So you might think, well, if everything that is a map always have to have keys as a string, then why would you give the option in the syntax to be able to define different types? And there's two reasons for that. The one of which is that you might want to, for documentation purposes, be able to say that the key is expected to be the name of the fruit. And that makes sense. Also, you can do what we would call narrowing. You can narrow the acceptable keys to a finite list. So we can say this object can only have 3 keys. It has to either be banana, apple, banana, or grape. A better example for this might have been first place, second place, third place, or an honorable mention A and B or something. I don't know. But also notice with this syntax, you've got the pipes. So you can take values and you can use the pipe to say, this type that I'm defining in line here is either the string apple or the string banana or the string grape. And this ends up being pretty neat because I have another slide later on that shows why it's pretty neat. But basically, you can't assign monkey as a key to this object. It knows that monkey is not a valid key. So you get type linting on that. Okay, let me move forward here.
Enum-ish.
Yes, we're getting to that momentarily. So a list is when the order is meaningful, that you care that they are in this specific order and that order matters and you want that order to persist. A map is for when the key or the ID is meaningful and the order is not so meaningful. All right, now we're going to talk about metatypes, enums. And you've already seen basically everything that we're going to show here, we've seen in some form. So we have value enums and type enums, and kind of implied enums in that JavaScript is duck typed. So certain sets of things always match. So in a value enum, in other languages, especially C, you'd be used to seeing a value enum like this, where you're defining some variable or constant, and then you're saying that its value is equal to an integer. And this turns out to be extremely boring, because these are weak sauce C-style enums, and C is not a good example of a typed language. It has extremely weak types. And then there's also, no, not going to go over that. What was my note to self? Yep, right there. Okay, so if we wanted to look at our previous example, this is an enum. So we've said we've created a type that can be one of three possible options: apple, banana, or grape. And that enum name is now fruit names. And like I said before, we cannot assign monkey to fruit. And then we could do the same thing if it were a function. We could have this as a param. It would know that I cannot pass that in as one of the possible options for that first parameter of this function. Okay, then we have Typey Nums, and this is interesting because in JavaScript you get to mix and match type and values because it's all just kind of loosey-goosey. But in general, a Typey Num, you can do it any way you want, which is, just because you can doesn't mean you should. A Typey Num is generally for things that are of similar type. So for example, I may have a function that can operate on any sort of list. It might be a very generic function like those kind that you see in Lodash, where maybe it can reverse things, or maybe it can get the last of, or maybe it can get the first of. Well, array, uint8array, array buffer, and about 5 other types in JavaScript all have this property by which you can use similar methods on them to do the same thing. And so this is where a type enum would make sense. And you could say, well, there's a broad range of types. They're all pretty similar, and they all have whatever it is that I need to do important things in common. So you could also say have maybe 2 structure types. One's a human, and maybe a human just sticks to the biological basics of what a human is. It's, eyes and ears and nose and age. And then maybe a person is a little bit more evolved. It's got a name, it's got a favorite color, it's got friends. So these 2 types would be similar in their structure, similar enough that you could have functions that might want to operate on something that is person-like. So you could define an enum and say, it's person-like if it's a person or a human. That's person-like enough for the types of things that I'll need to do.
Does it have to do with polymorphism, or is that not the same thing?
Let's see. We're going to get to that in just a second.
Okay, I'm sorry, I'm getting ahead.
No, it's actually fine. Whoops, let's turn that on. All right. So you don't, all of the patterns, every possible type pattern can be reproduced with what I'm showing you here. There is no type of thing that you cannot type with what is in this presentation, as far as I'm aware. So yes, that would be polymorphic-ish, but this is duck typed, so polymorphism doesn't apply in the same way, because duck typing implies polymorphism. Polymorphism basically says poly, many, morph, form, or shape. So many shapes. So the person and human are of many shapes, but they share common attributes. They're potentially polymorphic, depending on how you document it out. So this is a code smell, however. I want to distinguish between a good use of Typey Nums and a bad use of Typey Nums. This is a bad use because we could say, well, you can put a string, you can put a number in a string, and if it's a number, well, certainly it's a number. And if it's a big int, that's also a number. So there's different ways that someone could represent a number, and I'll just create a function that can take big number. And it could take a string or a number or a big int. And I'd say that this is a bad idea because you lose your types become weak, because these things are not similar in of themselves. A string could be banana. That is not similar to the number 42, which is not similar to the number of stars in the universe. So this doesn't convey much information to create a Typey num like this. Instead, I would say, have a function that takes in your big int, and that's what your function takes, because you can work with numbers of arbitrary size. If it's a large number that's a string, first convert it to a big int in one function, and then pass it into your function that handles whatever the big int function does. Likewise, if it's a small number, then first convert that small number into a big int, and then let it go into the big int function and do whatever the big int function does. Okay. And then, of course, there are some cases where you can't avoid this because of legacy code. If you've come across any JavaScript that's more than 5 years old, you're going to see the callback pattern where the first parameter is called ops, but in the documentation it said this can be your options or it can be a function. But if this is your options, then the callback parameter can be a function, or it could be nothing because you don't necessarily have to pass a function. And so then you end up with this type of weird typing that if you wanted to go back and type that legacy code, you'd have to create a value enum where it can be an object or it could be a function. And again, I'd recommend that you pass in greeter or whatever, some type of useful thing. I think that's why TypeScript was born in the day before promises were adopted into the language syntactically, which I think is why all functions are called callbacks, because TypeScript in the beginning did not let you have functions because it's modeled after C#. So the only functions that were apart from classes were callback functions. Maybe that's getting a little too into the weeds, but there we go. And then, like I said, implied enums, if it fits, it ships. So the example that I gave earlier of human and person, in truth, only for documentation purposes do I need to distinguish between human and person if person is a superset of human, meaning human has eyes, mouth, ears, nose, and then person has eyes, ears, mouth, nose, name, favorite color. So if it's a superset, then anywhere that I have a larger object that is more complete than the object I need, I can pass in that larger, more complete object, and that is okay to do. That it would be an implied enum. Type aliases, we've already shown this, but I'm going to give you a different example than what I have here. So we could type numbers as dollars. And this could be useful for documentation because there are places in our applications where we need to deal with things in different units. We have to deal with both meters and feet, depending on how the UI is displaying something. We have to deal with both dollars and cents, depending on whether we're interacting with an API or displaying something to a user. And so a type alias just helps us improve the documentation. It helps us say to the reader, this is not just any type of number generically, it is specifically meant to represent dollars. And you can also use underscores to help with that specific readability so that, if you see 2 zeros at the end, you know it's supposed to be cents. If you see 3 zeros at the end, you know it's supposed to be dollars. But the example that I would give here is that if you were to, well, no, I'm not going to give that example later. So then we have type anti-aliasing, meaning that we've said that a number is dollars, or we've said that this structure with name and age is a person, but maybe it's also a human. So there are times when we need to take from a set of types and an enum type, and we need to select a specific one. The best example actually would be files and folders. So if you want to list a directory on an operating system, you could get back a file, which is one type of thing, a folder, which is another type of thing with different properties and different behaviors. You could get back a symlink, which is yet another type of thing that could have similar behaviors and properties to either a file or a folder. Or you could have a pipe, which a pipe has the unique property that, unlike a file, you can read a pipe as a stream and get back different information than what you wrote to it. So all of these things can be directory entries if you list a directory in a file system. But they of themselves are not similar in the way that we were describing human and person earlier. They are similar in that they are just directory nodes, and they really only have one thing in common, which is that they have an entry in the file system table on a hard drive. And so what we might need to do when we're getting a list is say, well, if this is a file, there's certain things I want to be able to do with it. Because if I just take this dir entry and then I check to see what the size of the dir entry is, then I would get a little squiggly error in my editor, and it would say size may not exist on dir entry. And I'd say, well, I know that it exists because I just checked that it's a file. I checked if the type was file, and so I know that it has a size. It's not a zero size symlink. But with JSDoc and the type checker, you have to create a function that conventionally would be is whatever, and it has to have this at returns dir entry is whatever type, and then you do some sort of check. And this is completely useless in terms of the code. It doesn't help you, it doesn't help the runtime code at all, but it is necessary for the type checker. This is the only way that it can understand. So you pass in a dir entry and you say return file is equal to this, it's a Boolean value, and then if that returns true, then the type checker will know in the rest of the file, once you've done this check and it's determined it's a file, it will de-alias, it will de-enum it from being a dir entry to being specifically a file so that you can use it in the way that a file would be used, and it won't complain about the properties that are not common to the other bits. Okay. So, and then the obligatory example, if it's a duck and its sound is file, then it's a duck. That was supposed to be quack, of course. Okay, what we don't have, that if you come from a type ecosystem that you would hear about, are new types. So a new type this is not the right example, so I'm going to explain the right example instead, similar. So we want to say that we have salary is dollars, and then we have something else that's in cents, maybe price. So we're going to get something at the vending machine, it's priced in cents. We're going to get our salary is measured in dollars. You can't do math between dollars and cents, or rather you can, but you don't want to, because that will give you an error that's off by an order of magnitude of 100 in your code. And so many languages have new types, which is where you can use a similar type alias syntax, and you can say this is a number, this is these are cents, or this is dollars and this is cents, and never the twain shall meet. And if you were to do an operation such as multiply dollars by cents or add cents to dollars, you would get an error and you'd get a little squiggly. Because of the duck type nature of JavaScript and because of the supersetting and the way the enums work, we don't have the option. It's just not possible, as far as I could tell, it's not even possible to construct this pattern of a type in JavaScript. So we have to leave that one by the wayside. Yeah, like I said, because quack. And then we have mix-ins, which goes to our unions or polymorphism, different names for different people. But these are, the polymorphism is scary. I tend to not talk about it because it doesn't help you. That was a bad slide. So let's say that we have, I could probably come up with a better example, but if we wanted to define a mini type, a type extension that just says that something has friends. So maybe a dog could have friends and a person could have friends. Or maybe just a person could have friends. It doesn't really matter. But we can type def with friends and say the only property of this with friends type is that it has an array of person. Now, if we wanted to create a person with friends, then what we would do is we would use the and symbol, and we can type def whatever our base person is with the with friends type, and we get a type that is the union of the base person and the with friends. So what you get out of this would be that example that we showed before. In terms of the type checker, this is just syntactic sugar. It's no different whether we have two copies of it or we do the same. So I'm actually going to go straight to, let's see. Oh, and then we can add as many things as we want to. So we could have a base person and union that with the type with friends, and union with that with the type with posts, and then we could have a full person. And I think I actually want to skip to a particular example. I'm going to have to come back to it. That slide's just out of order. Okay, so let me go back here. Then we have templates, which are also known as generics. And these are for creating utility functions, things like Lodash, things that typically operate on either lists or maps, where the quality of the setness or the listness is what's important, not the quality of the content. So for example, if we want to get the last of something, and I'll show this right here. This is my canonical example. So we can define a template T, and what template means is just, it's a generic type. We don't know what type it is, and the type isn't really important. So it's just an array. It's an array that the type just doesn't matter. And so we can say it's an array of template T, meaning don't try to figure out if this is a person. Don't try to figure out if it's an array of fruits. It doesn't matter what type of array it is, because we don't care about the quality of that structure. What we're going to do is have a function that returns last. And so we're just going to say whatever the last element in the array is, return that. So there's nothing in this function where it needs to know if it's a person or if it's a dog or if it's a fruit. It only needs to know that it is a list and that it has list-like qualities. So if we were going to give this any sort of subtyping, we would say maybe array buffer, because all of those you could call last on and have it give a meaningful result.
So this is like a generic? Is that
Yeah.
what you mean by T?
Yeah, template, generic, it's the same thing. Yeah. So yeah, so we've got the T goes into the array, template T, and you can give this any name, T, U, V, K, M, L, Y, J. You can even give it a full name if you want. It's just typical. Typically you only need one. Typically you call it T. And what it can be useful for is like types. So again, we could say that I really don't care what type this is, except that it has to be person-like. It has to have some quality of personness, because we have a social security number. A person has a social security number. So any object that has a social security number, this function sanitize can operate on. And this function sanitize could turn their social security number into a masked social security number. So all we care is that it's T, but it's not quite any type. It's a type that's person-like, which we will define. And the parameter that gets passed in is P, which is of type T. And then this. So there is kind of a nuanced difference, because you could kind of just say, well, why don't I just put my person-like here and make that the parameter? And that would be perfectly valid, except that if I pass in a person here, I would get back person-like as the result type. Because I'm using a template, I can pass in a person or a full person or a person with friends, and what I get back will be the same type that I put in. That's why this is particularly useful. Because if you accept person-like, you can pass in a full person, but then you can't return a full person. You could only return person-like, if that makes sense. And then I think that this is just the same thing. I just repeated, oops. And then we have type utils, which is basically set operation for types or Lodash for types. So it's how to create a like type, a similar type. So for example, we just had our template. What we could do in this is we could say that to create something that's person-like, it could be a base person or a person with friends or a person with blog posts or a full person. And any of that is person-like if it's any of those types. But we could also just use this utility type called partial and pass in a full person. And what partial will do is it will say any properties that match a full person at all are person-like. So if I just pass in an object that has social security number and that's it, it's person-like. If I just pass in something that has a name and that's it, it's person-like. If I just pass in something that has an age and that's it, it's person-like. So if I do a partial on full person, then anything matching any of those properties is good enough to be qualified as person-like. And so this is just a way to define that. So there's a bunch of these. They kind of just do the inverses or opposites or contrapositives of each other. They're just set utilities. So partial takes whatever type you give it, makes everything optional, and says anything that matches any of these properties is of that type. Required says the opposite. It says maybe you define some of these could be null or some of these could be undefined. And this is going to say no. Everything must be defined. This is the type that is the complete type. Then you've got non-nullable, does what you might think. It just finds anything that could be nullable and then gives you back just those things. I don't really know why that's useful, actually. Then there's pick, which says, I just want these properties off of this type. And then there's omit, which is the opposite. I want this type, but I just don't want SSN. So these are just different ways to create permutations of types. Or combinations of types. Yeah, combinations of types. And then there's another one called read-only, which is if you want to make sure that this function never modifies a value of that struct, then you can mark it as read-only as just the parameter. You don't have to, with all of these things, you don't actually have to define them each time you use them. You can reuse the syntax anywhere. But read-only becomes person-like, or you can take a person-like and make it read-only, means it can read values, it can't write to them. And there's a whole ton of these. There's a big list of them, and if your head kind of spun a little bit or you got a little drowsy while I was speaking about that, that's fine. Because what I have to say about it is, just because you can, doesn't mean you should. Flat is better than nested. Avoid hasty abstractions. People just aren't great at recursion. Handle with care. So oftentimes, rather than using those things that were making your head spin, it's a lot better to just say, look, here's a base person. Copy, paste. Here's a full person. Added the things that make it a full person. So I want to let you know that there are situations where it is convenient and perhaps improves the readability of the code to use those utility types, the unions, the aliases, etc. But oftentimes, you're going to get the greatest readability out of just copying and pasting. It's where you have lots of combinations. You have new person for when you insert a person into a database, person query for when you need to be able to query a person from the database. You need full person, which is the person with their friends and their post to join. When you start to get to the point where you have 10 or 12 of the same type, that's where the copy and paste technique starts to break down, and you start want to say, well, maybe I should just define public person as omit person SSN, because public person is the same as a person, it just doesn't have an SSN, something like that. But I strongly argue that you should consider just writing the whole thing out or copy and pasting the whole thing out, because it is oftentimes going to be more legible. And then, so now, I don't know if I put the Q&A at the very end here. There might be somewhere. Oh yeah, follow, like, sub if you want to. Q&A.
Do you know if it recognizes, like, you were kind of doing right there, where if I were to, like, extension, if I were to have a fruit class, and then I were to say I have an apple and an orange that are actually classes of the fruit class, and I were then to call and say, hey, this has to just be one of the fruit classes. Do you know if the checker is smart enough to know about extension?
So yeah, you can define that. So TypeScript and JSDoc, JSDoc is born of JavaDoc, so it was not intended for JavaScript. TypeScript was created by the creator of C# to be a way to help C# developers transition into the browser. It was not developed for JavaScript developers or for use with JavaScript per se. It's just finding some common ground. So what I've presented on is the common set of JavaDoc and C# that can be fit into JavaScript in a idiomatic way. I would not recommend that you use extends or classes or inheritance, polymorphism. I would not recommend that you use any of those patterns in JavaScript because they are not patterns that are native to JavaScript. Before Microsoft invented TypeScript and started standardizing TypeScript as JavaScript, we did not have these types of patterns in JavaScript. We did have people that came from Java and started abusing prototypes to try to turn them into classes, but from the name prototype, you can tell that that's not what it was intended for. So yes, you can do all sorts of, anything that you can imagine can pretty much be done with the tools available to you in JSDoc and TypeScript. And I only showed things that are JSDoc compatible. There are extensions to JSDoc that only work with TypeScript that if you ran them through JSDoc, JSDoc would barf. Because I think that the idea that you're working for types and documentation at the same time is excellent. I did not show any examples that were TypeScript specific. Also, none of the examples that are TypeScript specific can't be replicated in JSDoc. They're just cuter. Maybe fewer lines or a syntax that's more pretty. But yeah. But with what you saw here, you could just do an and. You could do fruits and oranges and apples, and then that would result in a type that whatever fruits was before, maybe it was bananas and grapes, the new type that you've created also includes bananas, grapes, apples, and oranges. Yes?
The critics of JavaScript say, well, because it doesn't have type safety, you can't use it on a large scale. You can only use it on a small scale. Have you been able to use this on a larger scale? Do you have any experience with that?
Well, I'm trying to use it on a larger scale, and I would say yes, because this is precisely the same as what you get with TypeScript. This is types for JavaScript. So TypeScript is just a syntax change to JavaScript. It doesn't change the runtime. And one thing that I was going to say earlier is that what you've been told about types is a lie, because every language is typed. Every language. And it's just how those types are represented. And your favorite strongly typed languages, Go, Rust, etc., they are dynamically typed. You are told that they are statically typed, but this is, on the face of it, false. Statically typed only applies to tooling. If you can tell the tooling to ignore its checks and output a binary, if you can just skip that layer of the parser, the runtime will happily index into memory in the computer and pull out whatever is there. And this is why I say that C is I would never mention C in an example of a typed language, because to me, C is not as well typed as Python is. Python is at least strongly typed. The other bit is, what I was going to say is, so when you look at interfaces, when you look at reflection, when you look at these things that compiled languages have, they're dynamic. The only reason that the static compiled languages are usable at all is because of all of their dynamic features, that they can have the same things that you get in JavaScript, where under the hood there's a pointer, and the pointer has a type identifier, and when you need to pass that pointer, so it's really a meta pointer because it's a pointer, when you need to pass that around to some function that's an interface, it can check and see, hey, does this type match the interface, or rather not does it, because the static checks do that. What you're getting right now with this, the static checking does that, but then at runtime it has to sort, just like that is file function that I showed, that has to be done at runtime. That's what languages like Go and Rust have to do at runtime. The compiler has to generate an isFile function, has to insert it into the code, has to duplicate the code, and then your function that you wrote that's only yay long that can handle these three different types ends up either being three functions or a function that's 3 times as long with some ifs and switches in it.
Do you know if JSDoc has like a GitHub action or something like that? Because I think it's funny with TypeScript, I feel like some of the security feels like when you have to transpile it, it's going to throw those errors at you, so you can't actually build it without everything cohesively working. Just like with other compiled languages, you have some security in saying that this won't work unless everything fits together. With JavaScript, it's just, as far as we've talked about, just your IDE telling you, but you could always be like, screw it, production, let's go up and deploy it. Do you know if there's any type of I haven't really looked much at it.
So absolutely. So you can put there's multiple ways to do it. I would recommend putting it in your package.json and then in a Git hook, because that's the kind of the simplest way. You can, no matter what you do, you can get around it, right? Because even with TypeScript, all you have to do is pass -- ignore or whatever it is,
For sure.
and then it's going to emit everything as JavaScript without the type checking. So the nice thing about it is that it's turned on by default. The bad thing about it is that it literally takes, if anybody's used TypeScript with Vim, it's pretty much unusable, because their language server is so huge. I mean, if you like having lots of windows open and lots of tabs and stuff, but just to quickly switch back and forth between files, it's a nightmare. This, you still have some of that nightmare because the TypeScript checker is still running, but at least you don't have to have that big build step as well. Now I will reference something here if I can. Let me see. Oh, this is what is this doing to me? Okay, so I'm going to go to Beyond Code Bootcamp. Well, yeah, sure. We'll just go to GitHub.io and then I'll click on from there. So is that going to take me to the thing? I'm just going to take me to the thing here. To the thing, technical term. So I coded this up last night instead of working on the slides more because I already had some feedback on the slides. I still want your feedback on the slides because there's still plenty to be done there. But last night what I did instead was I created jsconfig init because this is the biggest problem that I had. Well, the two big problems were, one, not understanding what's the minimum set of things that I need to know. That probably seemed like you're drinking from a fire hose, and you were. But that is the minimum set of things that you need to know to describe everything that you might need to describe. And the two bonuses that I gave you that you don't need to know about new types in JavaScript, you need to know about new types to converse in the typed community. And you don't really need to use tuples in JavaScript because you're going to come across that use case twice in your career. But everything else is the minimum set that you need to know to be able to produce everything else in all the set of types. So what the presentation is a lot of difficulty. And I had a bunch of slides on how to do the configuration for your jsconfig.json file, but it's just too confusing to talk about. So instead, I wrote a tool that you just run npx jsconfig init. Boom. Now your project will automatically be recognized by VS Code as a typed JavaScript project, and you will get types. And what that does, the inner workings of what that does is explained here. It creates some files and some folders. It basically runs the type checker initializer with a bunch of options, adds some generic options that for some reason you can't pass directly, and then I probably should just automate this as well. Add, this is a copy and paste example, but I think I'll just include it in what it does. Set the lint script to be the type checker so that you can just run npm run lint and then you will get what you want. So you can put npm run lint. And I actually have another example that I'm not ready to post, but unfortunately with the way that TypeScript works, it has to check every single file in the universe. So if you have a gigabyte of dependencies, I mean, if you're working on a small project, if you're starting a project from scratch, this is not a problem. If you're going into an existing project and trying to piecewise upgrade it, and you've got a gigabyte of dependencies, the TypeScript checker is going to walk every single file and try to determine its types. And that's kind of rough. I think that there's some optimization I could add to the configuration to make it do that less so that it only grabs the typed types, because you can install packages that are at type, and then it can give you just the types for that, so it doesn't have to walk and actually interpret the code. But that's another beast. The configuration is by far one of the most difficult things to figure out because Microsoft's documentation on how to use the type checker with JavaScript is like in the links that I gave, there's a couple of other people's blogs that I referenced from, and over a few months of doing this now, I've gotten to a point where it's like, okay, if you turn on these options and you add this, it's really that simple. But to learn how to do that without someone telling you, give up, you're going to use TypeScript or you're just not going to do it. And so this right here will be in the final slides. This is jsconfig init. And this will initialize your jsconfig file. And you may want to change a couple of the options. For example, if you are doing an existing project, you would not want no implicit any. You would want to turn that from true to false. Because if you're doing an existing project, you kind of want to handle it on a file-by-file basis and work up to building things out. And this would give you an error on literally every single line of your code to start, which is not helpful. Yeah.
Thanks, everybody. That was awesome. By the way, do you use Vim?
Yeah.
Nice. I also am a Vimmer. I use Vim exclusively too. So
You-
love Vim. Love the Vim config.
You may very much like webinstall.dev Vim Essentials. This is actually on the homepage. So webinstall.dev. This is, by the way, this is the best way to install Node. This is the best way to install Brew. This is the best way to install just about all of the tools that you use on a regular basis, because this is a POSIX compliant, modern, works on Windows, Mac, and Linux for almost everything. Obviously, Windows has some things that can't be done. Conflict-free. You will not have to reformat your computer when things will not go wrong to the extent that you need to reformat your computer if you use Webby to install things, because it does it without root. So it doesn't touch your system files, so it cannot break your system. So it cannot ruin your installation of Python that's the system installation. This is one of the things I'm sure some of you have encountered. You install Ruby or you install Python, and you end up having to reinstall your whole computer because it messes up the system installed Python or the system installed Ruby, and all of a sudden system tools stop working. So webinstall.dev is the best way to install your tools. And there's a whole Vim section here, headed off with Vim Essentials. And this is basically a very non-controversial Vim setup. You can go to a Vim guru and have them look at, so you just copy and paste this one thing, and on a new computer, it will give you a Vim setup that is an acceptable IDE. And then there's a couple of things that are referenced as, hey, you may want to have these things as well. But this will give you an acceptable IDE, and Vim nerds can complain about anything because they're very particular, but this puts things in the correct directories. It makes the correct commented entries in your vimrc to say, this setting is in this plugin, and you end up with about a dozen lines in your vimrc.
Oh, I'm at like 2,000 lines in my vimrc. I have a lot, but I have several of those, so it's great.
Yeah, so
thank you.
these are very non-controversial.
Oh yeah. Well, awesome. Well, thank you for your time. We definitely have whoever wants to stick around and just kind of chat or ask questions. Feel free to. We're going to make sure we have a lot. So if anybody just wants to take some of the pizza, I'd love to make sure there's no pizza left over. So feel free to grab any. But thank you everybody for coming, and thank you AJ. This was awesome. Super great to hear about. So
I'm glad. Any ideas on how I can condense this down from? I think I did the presentation part in 35 minutes this time, and then the Q&A part for 35 minutes. Any idea how I can condense this down to 20 minutes and still have it be meaningful? Or just make it better. Maybe I can't condense it down. Maybe I pick 5 slides and say, I'm sorry, they scheduled me for a lightning talk. If you want to see the full presentation, check on YouTube.
Probably going to have to say for more, and then that could drive traffic to you.
Well, I want this to be the best presentation that anyone has ever given on typing JavaScript. And the presentation, unfortunately, is not necessarily geared towards amateurs. I don't want to alienate amateurs, but this is geared towards people that have worked with type languages to some extent, but is meant to fill in gaps for some of the things that, especially as a JavaScript developer, like Tuples and new types that you might not be familiar with. But this is intended for an audience of people that have been programming probably for a couple of years. But if there's ways that I can not alienate others, I'm interested in that. But I want this to be the best presentation. I want people to not have to go through the months of learning that I went through. I want them to be able to be productive and feel liberated and not feel like I hate JavaScript. I never want to use it in my life. This is the worst language that anyone ever created, because it's not. It is what Microsoft and people of large organizations on big committees have chosen to make JavaScript become over the past decade. The heart of JavaScript always had these types. This is just a way to document them and a way to have a linter that does what a linter should have done 10 years ago.
What is a linter?
A linter is something that checks your code. It checks your code for errors that will obviously cause your code to be incorrect, and it also checks your code for patterns that look like they are ambiguous or could result in an error.
Like if you ever seen the red squiggly as you're coding along.
That's the linter.
Yep.
Yeah,
That's
whenever-
Often they'll do like code styling too.
Universal solved.
What's that?
The universal solved. My answer to the universal solved.
Good. Glad that I could proxy the universe for you. I feel so large.
I think you need to change your title now, because now you just proxy the universe. Let's say, you just answer some of my questions.
Yeah.
You should add your where to like, sub, and follow here.
Yeah, that was at the beginning. I should put that here too, yeah.
What the universe calls you.
Yeah.
I mean, I'm already liked and sub, but if I landed there, I wouldn't know.
This should be the last slide. I'm going to keep that one in. I've done the slides twice so far. The first time I never actually did a presentation, and they weren't complete. And then the second time, and now I feel like what I give at the conference is probably going to be, every slide will probably be different from what you saw.
I do appreciate this though, because having gone to the conference twice, a lot of it's focused towards new people coming in, and it is fun to go and oh, this is in depth, and that's always fun to hear. So.
And then I will just check real quick to see if there was any more questions online. I don't see any. But also the chat broke and I had to refresh the page, so I lost any that were there. So if you're hanging around, you got a question, feel free to ask it still. I don't see anybody in on the Jitsi. Okay. But yeah, I'll stick around for more chat.
Yeah. I'm
Or
gonna stick around for
I'll walk away. I don't want to take any undue attention, but I feel like this is a topic that is really awesome, so I'm happy to answer more.
I was glad that you talked about interface. That was what I was thinking, because I do a lot of abstract concrete classes, because I did work originally in some C. And within PHP, I've tried to make it a little more strongly typed, actually, because we do a lot of PHP. So we actually use interfaces quite often, and we're very polymorphic in what we do. So it's fun to see the JavaScript. That's why we use TypeScript. We're trying to
Yeah, well, I mean, my argument is just you can have the goods without the baggage. You can have the chocolate without the calories.
Yeah.
And I, as you've heard already, I prefer the simpler style, because when you have TypeScript, it gives you every syntax in the known universe for every type system in the known universe. And that's it's too much to learn, and it's not helpful. It does not matter whether you union 3 types together or you create an interface with polymorphism. One is a little bit simpler to understand, and that's the one that I'd rather go with, because you get the same result. You get the same squigglies in the same places.
Yeah, I think where we've come, just because we'd rather have something take a little bit longer. Like our compiles for our transpiles for TypeScript is 4 minutes, right? And so yeah, it takes a bit longer. For at least for production, we do a lot more. And so, but we'd rather have a 4-minute with a bunch of checks than have any problems in production where objects get messed up or something like that. And so that's why we put a lot more on that layer, is because we'd rather have a pre-production crash than a production crash,
Yep.
And so that's where a lot of ours. That's why I bring up and that's why I would imagine JSdoc had something that was just in a GitHub action, because I agree sometimes TypeScript is a lot. In order for us to transition everything from JavaScript to TypeScript.
But the check is just a CLI command, right? You can throw
Yeah.
that in a GitHub action or whatever.
Yeah, so that's what I was saying is I just alias it to npm run lint. So I have npm run funct and npm run lint. And just because of really kind of the security fear, there's reasons I want to use ESLint, but it's just so large and so scary. Where was the thing? What we were just talking about? I was going to go back to that example. I don't remember what we were just talking about.
The command, the npm run lint.
Yeah. I put that in here. That's where this was. It's not in the slides yet. But yeah, this is probably the most important thing, other than the slides needs to become a blog post, because we need to actually have this as a quick reference sheet. There are a few others that exist out there, but a lot of them are coming from the Java or the C# land. They're not coming from Go, Zig, or primal JavaScript land.
Yeah.
And it's nice to know how to do things the simple way.
No, I think that TypeScript is overkill for a lot of applications. And so I think having a middle ground where it's hey, I'm still able to type, but it's not just the free-for-all that everybody complains that JavaScript is pretty cool. I didn't know that I haven't seen the JSdoc. It's funny, PHP actually had something very similar for a long time. They had PHP doc, And then that got converted actually into, now you can do strict types and stuff like that, actually native to PHP, and it does check it.
Yeah. Well, all checking always for every language is in the tooling.
Yeah.
The checking, well, all the dynamic types checking, the difference between a static language and a dynamic language is that in a dynamic language, you explicitly write out your is file check. And in a static language, that code is generated from the type annotation.
And some languages have the tooling more standardized, right? Like
Yeah.
Go, you like can't get away from the tooling.
Yeah,
It's
and
like
which
in
is
the tooling.
awesome.
Yeah.
I wish that there was an organ. It's so funny because everyone uses JavaScript, but no company is invested in JavaScript. No company has ever been invested in JavaScript. Maybe Google back in the days of the Clojure compiler, but still they were trying to make it into Java. They were not taking the approach of, we have a simple language that has structures, functions, and maps. That is literally everything. It's the Turing completeness of type systems.
You said something interesting that I wasn't aware of.
Yeah.
When were, because I also never use like the class syntax in JavaScript. There's a lot of things in JavaScript that I wish I could just, and I probably could if I battled hard enough, turn off in the language and say, we're never touching this, we're never doing it, ever, please, never, right?
Well, you shouldn't use classes for the same reason that React no longer uses classes.
Right.
You cannot have classes require synchronous state, and synchronous state is not a valid expectation in JavaScript.
Right. So, when you said they were introduced later, do you know when and by whom?
Yeah, well, so it was introduced back in the 90s by Microsoft, and it got rejected.
Okay.
So, and then they introduced it again in the 2010s.
Oh, see, I didn't realize it was that late. I thought I was familiar with most of the changes that happened in the 2010s, but I
No,
didn't realize that was a new thing.
Yeah.
It's terrifying.
Well, all the syntax changes to the language, almost all. I think there are 2 or 3 syntax changes to the language that were requisite. Big numbers. We needed big numbers. That was a requisite change. It's also having the underscores, I think, would be an appropriate, if you have to change the number syntax, might as well go ahead and introduce the underscores.
Sure.
Because the underscores add such great readability, and just like I said, being able to see 2 zeros at the end versus 3 zeros at the end is literally, literal is a strong word, not a lifesaver, but a job saver. And then async await, actually having the base, because most implementations of JavaScript don't support async. They don't support callbacks. Most implementations of JavaScript are completely synchronous. They have
When you
no
say most implementations, which ones are you referring to? Other than
JScript, Rhino, CommonJS. I mean, there's so many dozens of implementations of JavaScript that, well, maybe not, maybe
because I mean,
between a
Node
dozen
and
and 2
Chrome
dozen.
don't make up the majority of implementations, but they do make up the vast majority of actual runtime. Right?
I'm not sure if that's true. We probably are right about there, but that's kind of like saying that React isn't the vast majority of implementations, but it is the vast majority of deployments, which is simply not true. WordPress is the vast majority of deployments.
No, that's
and
definitely true.
and then jQuery would be number 2 after
This
WordPress.
must be a world I'm not familiar with at all, because to me it seems like the browser and Node would just be
So
like
if
80+%.
you if in the 2000s you had a embedded device from Texas Instruments, the build system was written in JavaScript, and the implementation of JavaScript was insane. It had includes. It was very much like PHP. It had includes, and everything was a global. So you simply included one script from the
giant variable and everything.
or you
on
didn't,
that.
or you didn't, or you just had to look through literally thousands of lines of code. You'd have to use your grep skills to the max, and then end up, because the way that the environment variables were loaded were not necessarily clear or syntactically different either. And so there's a lot of times where after you grep through and look over a line, 500 lines where something is, there was never a place where it was defined, because it was actually the engine loaded things in configuration and then did some sort of process to them, lowercasing them or whatever, and then spit them out into the global namespace before the execution ran. And so you could just have globals that it was literally not possible to find out where they came from or how they were set unless you knew.
JavaScript was garbage from the beginning.
Well, that was not the beginning. That was the bastardization that was introduced by, probably we could blame that on Microsoft because,
I'm just kidding.
JavaScript.
JavaScript is easily my second most used language. Like,
yeah, but you don't love
and
it.
then I use JavaScript.
But you don't love it.
I like
But you
it
could.
once we can. Well, I like it once I'm writing my kind of JavaScript. Which
Yes.
When you take out that 50%.
I think 50%'s a little low, but maybe 70, 90%?
Yeah. Like I think it's super important to understand how that percent works because you will see it, and that's the problem, right? You will run into legacy code. We can't all just have our way all the time.
Well, this
but-
is. I think I told you about this. I
I
want
avoid
to create my own language that runs in a browser, and it will be a clean break from JavaScript, but it will run in a browser without any problem or transpilation.
What's your plan for getting the browsers to support it? Or are you going to transpile?
No,
Or
there will be
WebAssembly?
no transpiling, and the browsers already support it.
Which is what?
Well, it's the language that I want to create
No, I understand that, but I'm saying, how do you get the browsers to support it?
because they already do. Because the language that I want to create, I'm creating that language out of a set of constraints that fits inside of
Inside of JavaScript.
the JavaScript runtime.
Perfect.
But would
That's-
not be JavaScript.
Right.
And there would be a tiny
Rather
amount.
than typeset being the superset of JavaScripts, we want the subset of JavaScript.
Yes.
Yeah.
And the what was I going to say?
Cleverly named subscript.
So I thought about that actually. I've got a list of names that I might call it one day, but there are some issues because you have to carry over some historical things that are difficult. Oh, I was going to say so there would be a tiny amount of calling it transpilation would be maybe a little bit hard, but you know how Go has automatic imports? We wouldn't call that transpilation, but it is, if you write the code and you don't write the code with imports, that's fine. You, as a developer, don't ever need to write an
Save
import.
and they populate.
Right. But there is, what you write is not valid Go. What you have after you hit save is valid Go. So there are some things like that I would like. So for example, there would be a macro for arrow function syntax that would create a proper function. There would be macros for some other things similar to that, so that I would also have a macro for the typing, so that in order to be compatible with JSDoc, because I can't create the whole ecosystem, so I have to be compatible with TypeScript and JSDoc and JavaScript, and I have to find the subset that fits in all of those things. Otherwise, I have to create the entire universe myself, and I can't do that. So first I have to define the language, and I have to say, well, on the path to creating what this language should be, which should have a syntax that is geared, a syntax for JavaScript developers to have, like JSDoc. But in the interim, and that would have to be just like with Go, that'd have to be an auto upgrade thing where it can look at all the comments, parse all the comments, and then boom, auto upgrade. You hit save, you have the new version.
Would you really want to go down the path of comments, though?
Hmm?
Would you really want to go down the path of comments for your type system?
Yes, because it's the only way that it can work. Because otherwise you have to have transpiling. Comments can be ignored, and so you can hit save, and you could write a function and not have anything about the types in it. Hit save, and have it done. And then I would put an @draft. And so the @draft tag would mean that anytime you save, it's going to consider the function canonical and the documentation inferred. But once you delete draft, then if you deviate from what the function is, and there would probably be a command to basically say, okay, anytime you tag something, anytime you run AJScript version patch, then it would delete all the drafts, because that's saying if you're publishing, you've finalized.
Yeah. Well, that's cool. I like the idea of avoiding transpilation. That's nice.
Thank you.
Did you have any questions or anything? You're just sitting around for the conversation?
Yeah, just absorbing. Most of it's going over my head right now because I am amateur, but thank you.
Yeah.
It's a good presentation.
Well, I hope that. Oh, we do have some comments on the online. I'll get to that in a second, y'all.
Another piece of pizza.
So you're committed to the JavaScript path, or you're ambivalent? You're considering which path to go on.
So like I'm gonna start with JavaScript just because it's so widely used.
So I would recommend that you use that tool that I created last night. Do you have any of where these things are?
Yeah, I took notes.
Okay, cool. So these things will get updated. Right now, those slides are not actually linked on that website, but they will be soon. I'll probably do that tonight. And I'll try to get the slide in that has that JS config init, because basically, if you can get the JS config init thing, all the other stuff you can learn through trial and error.
Yeah.
Meaning there's reasonable documentation that you can go to and reasonably understand. Getting the config set up is not something that you can reasonably understand.
Yeah. Well, that's pretty cool. So, thank you.
You're welcome.
Also, like you mentioned, like trying to, when you do it, not make amateurs feel like alienated when they come to it. I think that there's like no way for you to condense that down for amateurs, but I was really interested when you started with like the statement about like Go and like stuff and not writing off JavaScript because of the TypeScript. And so maybe like, I think that's the biggest takeaway I had. So like coming around and hitting that point again at the end, like why? Because as an amateur, I don't know why from what you were saying.
So here's another website that I would recommend that you take down. I'm going to take just 1 second real quick to make a comment on like there's a difference between discrimination union to interface. With interface, you'll get your child types know about the parent, while discrimination union child types do not need to know about what is binding them. You are actually above my head a little bit because I am not really that much into the computer science of it. Should PHP be a front-end language? That's what React is, literally. You have the largest PHP company in the world created a framework that mirrors PHP to run in the browser. What do you think about the Elm language? I don't like things that you have to transpile. So I prefer languages that are of themselves. Also, I'm not big on functional languages because it's too much, what's the word, maybe pedagogy? There's too much. I mean, just giving this presentation, I felt because we're talking about types, I have to get really computer sciencey and use really big words. And when you start going into functional programming, you just have to use big words senselessly. And then you have extremely terse syntax that's difficult to explain and completely non-obvious. So I don't really like the functional languages. I understand benefits of functional programming, but I don't like languages that do that stuff. So what I was going to say is, so Creeds of Craftsmanship, this is a site where I'm putting together talks, manifestos, blog articles, stuff that I think are the highest quality on the internet of how to learn software engineering. Not programming, but software engineering. Because programming is the universe of anything that will run as a program is programming. Software engineering is constraining that to what are the best methodologies that you can internalize to write code that is easier to read, more reliable, resilient against changes in versions, etc. And so Zen of Python, Go Proverbs, Zen of Zig, these three languages all have a ton in common because they kind of pay homage to each other. So Zen of Python is 19 stanzas. When they came out with the Go Proverbs, I don't think that it was any accident that it is 19 stanzas. Also in a blog post, the Go authors reference Python as Go being the spiritual successor to Python, as reimagining Python in the modern day. Python was created before the internet. And so Python sucks as a programming language for what a lot of people use it for. You really have to kick against the pricks to get Python to do this stuff because it just was made in an age when these things weren't imagined yet. And then Zig is a reimagining of C. It's kind of a spiritual successor to C. And so Zen of Zig is very similar to Zen of Python. I mean, Zen, the Go proverbs. So they all kind of pay homage to each other, and they have similar stanzas in their philosophy. But it is a spiritual text of guidance for software engineering. And I actually did have a presentation. If we just search on YouTube Zen of Python, I think I would imagine that the presentation I did, being one of very few presentations on the topic, maybe if I could spell it right. Yeah, there we are. So, anyway,
Thank you so much.
you're welcome. All right, everybody, I'm signing off. Thanks for joining in. Adios. Oh, there's more of the questions right there.